Let's look at question number 1. The question, we have a hummingbird. This is the bird that has a mass of 3.6 times 10 to the negative 2 kilogram. And we got a baseball that has a mass of 0.145 kilogram. The question says, if the kinetic energy for the bird is equal the kinetic energy for the baseball, we can't use B and B. Let's use C here, I don't know, bird, canary, whatever. If the kinetic energy is the same, can you tell me what is the ratio? Can you find the ratio of the potential, the linear momentum for the bird to the linear momentum for the baseball? Well, linear momentum for each one is the mass of each one times its velocity. The problem is I don't know the velocity of either one, but I know the kinetic energy. Well, the kinetic energy for the bird is 1/2 the mass of the bird times the velocity of the bird squared. 1/2 the mass of the baseball times the velocity of the baseball squared. So it's 1/2 the mass 3.60 times 10 to the power of negative 2 times VC squared equals 1/2 the mass of the bird, which is 0.145 times the velocity of the bird squared. Now, what is the when you do the math here, notice the 1/2 actually mathematically will disappear. It's okay to erase them mathematically. And you end up with 3.60 times 10 to the negative 2 VC squared equals 0.145 VB squared. If you divide both sides by 3.60 times 10 to the negative 2, you'll have VC squared equals 4.03 VB squared, which means VC is going to be the square root of 4.03 VB squared. And we know from math you can break this one down to the square root of 4.03 times the square root of VB squared. So VC equals the square root of 4.03 is 2.01, and the square root of VB squared is just VB. So that gives me a relationship between VC and VB. Now let's find the ratio here. The question, what's the ratio of the linear momentum of the bird to the linear momentum of the baseball? Well, it's 1/2 the mass of the bird. Oh, there's no 1/2. Linear momentum is mass times velocity. It's the mass of the bird times the velocity of the bird over the mass of the ball times the velocity of the ball. Well, the mass of the bird is 3.6 times 10 to the negative 2, and the velocity is VC, which happens to be 2.01 times VB over 0.145 times the velocity of the bird, which is VB. And what will happen to the VBs? They will cancel each other out. and we end up with PC to PB equals 0.498. Now, part B of the question is a little bit different. Part B it says we have a man always wears a hat, and when I draw him, and we have a woman here, always has the long hair. The weight of the man is 750 Newton. They don't give us the mass. Well, we know weight equals mass times gravity, so we can get the mass of the man to be 750 divided by 9.8, which is 76.5. The woman has a weight of 500 Newton. Weight equals mass times gravity. The mass of the woman equals 500 over 9.8, which is 51.0 kilogram. The problem said they have the same momentum. Well, we know momentum is the mass of the man times the velocity of the man should equal the mass of the woman times the velocity of the woman. What is the mass of the man? 76.5 times his velocity should equal the mass of the woman, 51.0 times her velocity. And if you do the math, divide both sides by 76.5. The velocity of the man is 0.667 the velocity of the woman. The woman is actually moving much faster in this case than the man. He's only 2/3 of her speed. Now the question here is not finding the ratio. The question, what is the ratio of their kinetic energy? So the question was, find the kinetic energy of the man in relation to the kinetic energy of the woman. So let's see. The kinetic energy of the man to the kinetic energy of the woman. Kinetic energy is 1/2 the mass of the man times the velocity of the man squared. The woman, 1/2 the mass of the woman times the velocity of the woman squared. The mass of the man is 76.5, and the velocity of the man, which is 0.667 VW squared, you got to square that, over 1/2 the mass of the woman, which is 51.0, times the velocity of the woman squared. And notice the velocity of the woman will disappear because they're both squared, so that's gone. So what's left, and the 1/2 is also gone. So mathematically this will be 76.5 times 0.667 squared over the 51.0. And that answer is 0.667. So the ratio of the kinetic energy of the man to the kinetic energy of the woman is 0.667. That was question number 1, part A and B. question number 8, that was question on 8. 8 has like 6 parts. I'm not going to do all 6, I'll just do 1. It's the same process, every single one of them. So I'll do it for 1 and show you how to find theta for the first one, then go ahead and do it for the other 5 of them and see which one is bigger, which one's smaller. We have a car approaching intersection. The car has a mass of 1,000 kilogram and it's moving in this direction toward the intersection with the speed of 10 meters per second. We got another car in this direction and it's moving that direction. This also has a mass of 1,000 kilogram. It has a velocity of 7 meters per second. They collide and they're going to stick together. The problems assume they're stuck together and they're going to travel in this direction. That's V final and this is theta. Can you tell me what theta is? That's what the question is. We don't care how fast they're moving, but then we just want to know what the angle is. Since you have 2 dimensions, you have to break it down to x direction and y direction. In the x direction, the linear momentum is a vector, so it's the mass of this car, which is 1,000, times the velocity of this car in the x direction, which is 10. I'm using this way as x is positive, this way as y is positive. Plus the mass of this car, which is 1,000, but in the x direction this has a velocity of 0. Now the 2 cars collide, they stick together. So they become one object. It has a mass of 2,000 kilogram. And the velocity in the x direction is going to be Vf cosine theta. Clean it. 10,000 equals 2,000 Vf cosine theta. Divide both sides by 2,000, you have 5 equals Vf cosine theta. In the y direction, this car has a linear momentum of 0 because it wasn't moving the y direction. This car is 1,000 times the velocity, which is 7, equals the sum of the 2 cars, that's 2,000, times the velocity in the y direction, which is Vf sine theta. You got to find the component of this velocity in the y direction. 7,000 equals 2,000 Vf sine theta. Divide by 2,000, you have what? 3.5 equals Vf sine of theta. And that's your second equation. Take the 2 equations now and solve them for theta. So here we go. Solving for theta. So we have the first equation says Vf sine theta equals 3.5. I wrote the sine first intentionally. The other one, Vf cosine theta equals the 5. One easy or quick way to solve this is you divide the 2 equations by each other. When you divide, this one cancels this. The reason I wrote the sine first, because I know sine divided by cosine is actually tangent theta. 3.5 divided by 5 is 0.7, and to get theta is the inverse tangent of 0.7, and that will be what? 35 degree. And you can repeat the process for the other 5 parts. Same thing. Different masses, different velocity. I'm not sure why they gave you 6 problems, the same thing. 3 would have been plenty. Number 14, it's a tough one. You have, this is the cue. You're playing pool there, and you shoot the cue here, and you hit the number 9 on the side. What happens, the cue will go in this direction. With the velocity of VF. We'll say C for Q. And the number 9 is going to go in this direction. We'll call it V9. The only assumption they're saying, assume these angles are equal. The way they're split, these angles were equal. And they didn't give us the mass, or they didn't give us the initial speed of this one, unknown to us. And the question here, can you tell me what theta is? Find theta. So I'm going to have, this is elastic collision. We have conservation of linear momentum, and we have conservation of kinetic energy. Linear momentum is a vector, so I got to deal with that. Let's look at the kinetic energy. We'll do the kinetic energy first, because I only have a little space here. The kinetic energy before, that's, well, maybe I'll do the linear momentum. There we go. Let's talk about x initial linear momentum should equal the final linear momentum. Let's look at the x direction. The mass of this was not given to us, but pool table have the same mass, all the balls have the same mass, times the velocity in the x direction, VI, plus the mass of the 9 ball times the velocity in the x direction, which is 0, wasn't even moving, equal the mass of the Q here. I'm using, this is positive x, this is positive y. The Q went up there, which has an x component. And the velocity of that in the x direction is VF cosine theta. And the 9 ball has a mass m and a velocity in the x direction of V9 cosine theta. Since every one of these has m in it, mathematically I can just take the m out. So in this, that says VI equals VF cosine theta plus V9 cosine theta. And that's my first equation. I'm going to have 3 equations by 3 unknowns. That's equation 1. Let's do the y direction. In the y direction, this has a linear momentum, the mass m times the velocity, which is 0. This has a mass m times the velocity in the y direction. That's also 0. This has a mass m, the q, times the velocity of vf sine theta. And the 9 ball, the velocity is negative because in the y direction is coming down, v9 sine theta. Again, every one of them has m in it. This is equals, not a plus here. The before equals the after. 0 equals vf sine of theta minus v9 sine of theta. Move this one to this side. v9 sine of theta equals vf sine of theta. Well, what do you know? You have sine theta on both sides. You can divide both sides by sine theta, and sine theta will disappear. That tells you that v9 equals vf. And that's equation number 2. That's equation number 2. Now we need to do conservation of kinetic energy. The initial kinetic energy equals the final kinetic energy. Now kinetic energy is not a vector, so we're going to use 1/2 mv squared. 1/2 m, the velocity here is vi squared, plus 1/2 m, the velocity of this 0 squared, equals this one here, 1/2 m times the velocity v final squared, plus 1/2 m, and this is v9 squared. Notice 1/2 m, it's in every one of them. Vi squared equals v final squared plus v9 squared. And that's my third equation. Here's the good news. Equation 2 tells me Vf equals V9. So let's do a substitution for them. If Vf equals V9, let's take equation number 1, that's this one, and replace Vf with V9. V9 cosine theta plus V9 cosine theta. So Vi equals 2 of them. Let's also do a substitution for Vf equals V9 into equation number 3. So here's my new equation now. Let's do a substitution here. Vi squared equals, instead of Vf, go V9 squared plus V9 squared, which means Vi squared equals 2 V9 squared. Vi equals the square root of 2 times V9. That's also from equation 3. This is from equation 1. You let VF equals V9. Now notice it says VI equals this and VI equals that. So set the two of them equal to each other. So let's set them equal to each other. Here we go. Instead of VI, let me put the square root of 2 times V9 equals 2 times V9 cosine theta. V9 will disappear from both sides if you divide by V9. Let's divide by 2V9. Cosine theta equals the square root of 2 over 2. Theta is the inverse cosine of the square root of 2 over 2, and theta will be 45 degrees. That was a tough one, mathematically. And the last question, 18, we have number 18 here. We have 3 bricks identical, same length. The other one sits on top of it. That distance is 1/2 the length of the brick. And the third one sits 1/4 of the brick. This is the 0. The distance here is L. The length of it is L. The mass is the same for all 3 of them. And what is the center of mass? If you remember X center of mass, it's mass 1 times x1 plus mass 2 times x2 plus mass 3 times x3 over the sum of the masses. Each one of these bricks is going to have a mass right in the middle of it. For this will be right there. For this will be right here. And for that it's going to be right here. So for the first one, since the mass is the same, is going to be m times the distance from here to there. You can see it's half the brick. Plus, the second one has a mass of m, and the distance from here to here, which is L. And the next one is m times the distance from here to here. Well, what is that distance equal to? Well, we know from here to there is half an L. This is 4, and this is half. Half plus 1/4 plus half of L over the sum of the 3 masses, identical masses. Now if you go to the side here, what's 1/2 plus 1/4 plus 1/2? LCD is 4. That's 5 over 4. So I can take the m out. This will be L over 2 plus L, and this will be 5 over 4L over 3m. and the m's will cancel each other out. So it's 1/3 of these guys. Well, that's L over 2 plus L over 1 plus 5 over 4L. Well, if you want to add them, you need the LCD, which is a 4. So what's 1/2 plus 1 over 1 plus 5 over 4? LCD is 4, 2 over 4 plus 4 over 4 plus 5 over 4, that's 11 over 4. So it's going to be 1/3 times 11 over 4L, which is 11 over 12L. The center of mass will be 11 over 12L, which is the length of the brick. And these are the homework questions.